Today's lesson in optics is going to be looking at different types of mirrors. We'll look at plane mirrors, concave mirrors, and convex mirrors. First off, we're talking about reflection, that we describe the path of light, or photons, as straight line rays. Reflection off a flat surface follows a simple rule. Angle in, right, the incidence equals the angle out, and this obeys the law of reflection. Angles always measured from the surface normal, or from the normal line that we'll call it. So my incident ray, this angle relative to the normal, must equal the reflected ray, and this angle here must be equal to this angle here. And this, of course, is what we're talking about, a plane mirror, where it's a perfect plane itself. So when we look at the images in plane mirrors usually have flat, shiny, specular reflective surfaces, where light comes in and reflects off very nicely. So when we look into a mirror here, rays seem to come from behind the mirror, but of course they don't. It is virtually as if the rays were coming from behind the mirror. So really we create virtual images. If light energy doesn't flow from the image is virtual. Virtually, it means the same as if. So as far as the eye and brain system is concerned, the effect is the same as would occur if the mirror were absent and the chess piece were actually located at the spot labeled virtual image. So as light reflects off of the surface of the chess piece, it reflects off the mirror, obeys the ray diagram rule, and the law of reflection reaches our eyes. So we perceive it as being over here on the side. It's almost as if the chess piece is here, but it's not. There's no light that travels along this path. It's the way we perceive it. And therefore the top of the chess piece, light is going to reflect off it. It's going to reach our eyes. And we recreate this image over here that we call a virtual image. It's not exactly there. We know this. But it's the equal distance, the equal size, just on the other side of the actual mirror. So looking into a plane mirror. So the image you see in a flat mirror is the same distance behind the mirror that you are in front of it. Since the light is not coming from behind the mirror, this is a virtual image. So here's an individual looking into a mirror, sees a virtual image over here. Images in plane mirrors are always virtual. They're always right side up, they're always the same size, and the image distance equals the object distance from the mirror. So if you're standing 1 meter away from the mirror, your image is going to appear 1 meter away from the mirror. So in other words, your virtual image, if you're 1 meter away, is going to appear 2 meters away from you. The key difference looking into a plane mirror is that it's got left-right reversal. So if you write out the word ambulance backwards in your notes, you would see that if you looked at it in a mirror, you would actually be able to read it. So why is the word ambulance written backwards in front of a vehicle? Well, so when you're looking in your mirror, you can actually read it as it is. So remember, your right hand is going to be viewed as the left hand virtual image. Equal distance, equal size, just on the other side is going to appear to be of the specular surface of the mirror. So if and when we were to draw this, I want you to see how, if this is the object we're looking at, and this here's the mirror itself, so don't get caught up in all these arrows yet. Take a look here. If this arrow, if we're looking at this arrow, we would see the virtual image of the arrow over here. So objects are real physical things that give off or reflect light. Virtual images are formed when many rays on an object appear to come together again. In a mirror, light rays do not actually come together. It's a virtual image. So if this is the arrow, and we see it as this image over here, here's what we have taking place. Light is going to move in all directions. Well, if we were at this location right here, we would actually appear, the front of the arrow would appear directly straight across. So when we look at our picture, remember this arrow, if light was reflecting off it, it reflects into the mirror, and one could see it, we would actually see this equal distance, equal size, only left-right reversal within the mirror itself. So let's get a couple terms straight, some vocabulary. Virtual images, they are not real because it cannot be projected. Image only appears to be there, and they're always right side up. The only key is that they're left-right reversal. But a real image, the image is made from real light rays that converge at a real focal point, so the image is real. They can be projected onto a screen because light actually passes through the point where the image appears. And they are always upside down. So let's consider curved mirrors, right? No longer planar. Plane mirrors are flat. Curved mirrors are not flat. We will study 2 different types of curved mirrors. We'll look at concave mirrors. These are what converge light. If I look at this concave mirror, notice the light is coming from the left. It's coming in. It's going to strike this. Notice this point of reflection is going to move inward due to the angle or the curvature of the mirror. And this is going to angle inward as well. And where all of these rays, here's another ray coming in. It's going to reflect back. The point where all of the light rays converge is called the focal point. That's called the focus itself. In a convex mirror, diverges light. So converges means it comes together. Diverge means it spreads apart. So if I look at light rays here, it's going to strike the curvature of the mirror. Notice it's a little different curvature. So a convex here, we're talking about light is diverging. It's bouncing and spreading outward. So when I look here, if I look at this ray here, this would appear, if I look straight ahead, the focus is actually on the other side. Here the focus is on the inside of the curved mirror, on the inside. It's on the same side as the light's coming from. On a convex mirror, the focus is on the opposite side of the mirror. So what if the mirror isn't flat? Well, a concave mirror converges light into the one location called a focus. This is an example of a curved mirror, concave. The focus of the concave mirror is located in front of the mirror itself. Bingo, right here, focus. This is where all the light converges into one point in a converging mirror. A convex mirror diverges light. The focus is located behind the mirror. So let's look at these pictures over here. This picture here, hopefully you realize that this is a convex mirror. So you're actually going to appear smaller in the convex mirror. We'll talk about why that is here in just a few moments. And here we have a concave mirror. When an object is close to a concave mirror, the image can be larger than the actual object is, so you're actually magnified in size. So we're going to start off with concave mirrors. Concave mirrors, they are converging mirrors where light is converged into a focal point. They have a real focus, and notice the focus is located on this side, on the inside of the mirror. They are curved inward, right? Hence this location. You can think of it like a cave. You can actually put your hand in here. And they may be real images or virtual images. If you're inside here versus outside the focus. So we know this picture here is a concave mirror. Then this person here would be inside the focal point. They are right side up and they are magnified. It amplifies the picture. As is this kid. Big head. He doesn't really have that big of a head. He's just inside the focal point. But notice the person outside the focal point is going to be upside down. So concave mirrors have very specific characteristics when we look at them and we see the images. So we're going to look at this concave mirror. We're going to do a little what we'll call a case study. We've got 5 different locations where we are relative from the mirror. Here's the mirror, here's the focal point, and here's a location here of the center of curvature. So here's what I have. We've got 5 locations, 5 different parts that we'll look at. So make sure you may need to rewind this and check this out and watch this a couple times. Case 1, right here. The object is located beyond the center of curvature, out here. So if the object is located beyond the curvature, it's an inverted real image, right? Inverted, it's upside down. Object is out here, upside down here. Case 2, the object is located at the center of curvature. It's an inverted real image, upside down. Right? So we're talking about different locations along the plane of the mirror. So case 3, an inverted real image, if you're outside the focus but yet inside the curvature, right, between the center of curvature and the focal point. So it's going to be upside down but a real image. Case 4, if you're at the focal point, no image forms. All of the light is passing through here at once. And lastly, case 5, if you are inside the focal point, you are going to be magnified as an upright virtual image. So our case study allowed us to look at this concave mirror, and if we're standing out here, here, so here was case 1, case 2, case 3, case 4, and case 5. Case 5 is going to be a larger image. This person here would be at case 5. If you're at case 4, there's no image. All of the light is here. You cannot make sense of what that light is. And the further you move back, it's going to be upside down, and they're just going to look a little bit different. So the case study allows you to kind of sort out what's going on here as to where you're located relative to the concave mirror. Moving on to convex mirrors. Light is diverging. It reduces the image, right? They're smaller. They have a virtual focus. The virtual focus will be on the opposite side of the mirror, and they will be right side up. So this side we're looking at light coming here. It's diverging light. Remember, the light here in this picture is coming from the right-hand side. So a couple terms that we need to make sure we get here is light is diverging. It's striking this and it's reflecting from the surface. Remember, we're looking at curved mirrors. So this case, if light's coming from out here, it's going to reflect the light outward. But as a result of this convex mirrors, we actually see a larger field of view. So the image must be smaller that we see. So it allows us to kind of see around corners. Our rear view, or the mirrors that we look at on cars, objects in mirror are closer than they appear as a result of the diverging of light. And the bean in downtown Chicago is actually a very nice diverging convex mirror. So the last part of this is these are the mirrors I have in class. So which flip, which switch. Okay, that's just gibberish. That has nothing to do with anything. But what I can do is we can look at these mirrors and make sense of them. So which mirror is which? Is it concave or convex? So look at the images created by the mirrors, determine the mirror, and explain how light reflects off of each image in the mirrors. Now I'm going to ask you to kind of pause and rewind this and try it. Now in about 10 seconds I'm going to have you pause it at this point and try to determine which mirror is which and where I'm standing relative to it. So look at the image in the picture and determine what is going on, what is happening, and where am I standing relative to the focus, or at what distance I'm at away from based on the picture. So if you'll take a look here, you should see that this is a convex mirror and this is a concave mirror. The convex mirror, I'm standing a little ways away from it. You can actually see me here taking this picture, and you'll notice that this is a virtual image and I am smaller because it's getting a much larger field of view. But this is the concave mirror, and according to this, if I'm upside down, you would find that I am located further away. I'm outside the focus. Notice, if I'm upside down, I have to be beyond the focus itself. If I'm at the focus, there's no image. And if I'm within the focus, I'm right side up with a larger picture. I hope that makes sense or helps with mirrors.